Okay, so we have this interesting exponential equation here. It says x raised to the power 3 log x equals 10x squared. Just by looking at it, you might just try to just adjust the right hand side to look like the left hand side. You might want to make the right hand side x raised to the power something, just like how the left hand side is x raised to the power something, and then you cancel out the bases. But it's not going to work out because we have 10x squared. We have 10 as the coefficient of x squared here. So we can't make the whole right hand side x raised by something. So, but there's a way out. We could take the log of both sides and see how it goes. So let's take the log of both sides. So applying log to both sides, and this time around we are going to apply log to the base 10 to both sides. And mind you, the log x here has a base of 10 also. So taking log of both sides, we're going to have log base 10. Then we write out this value, x raised to the power 3 log x. Of course, I told you that there's a base 10 here, so you can actually make the base 10 show to make your work look more perfect. Equals, then you apply the log again to the right hand side, log base 10. Then you fix your 10x squared. Very easy. Then, of course, following laws of logarithm, the power of the number can move over to this side and become and stand in as a product with this log base 10. Don't forget, this is the power here. Let me make that very visible. So the power of the number x is this whole value here. So this one moves over to this side and stands in as it will be in product with the log x base 10. So let me just rewrite that. So this one is moving over to become 3 log x base 10. Then I'll still write out my log. I can put a dot product. Then I'll have my log x base 10. Mind you, this log x base 10 is still here. Then you continue equals. You have your. Then you can still break this one down following addition law of logarithm. And this is the addition law here, where you have log a. Of course, it's in base 10. Log a plus log b equals log ab. Then reversing it, you also have it this way, that log ab equals to log a plus log b. So let's just apply this law here. So we're going to split this one. So this log 10x squared to base 10 will now become log 10 base 10 plus log x squared base 10. So I just followed exactly what we have here, this format. So that's it. So I'm going to reverse this one following that particular law. So reversing this whole value following the law of logarithm, addition law, I'll have log 10 base 10 plus the x squared now, log x squared base 10. So, and yes, these two can also move over to this part and standing as a value that is in product with the log x base 10. So rewriting this, log x base 10 times log x base 10 gives me log x base 10 all raised to the power 2. So it now becomes something like this, log x base 10 everything raised to the power 2 equals log 10 base 10. When the number and the base are the same thing, you know it's 1. So this is 1 already. Plus, then the 2 moves over to become 2 log x base 10. And that's it. If you notice that, if you check where, you will notice that I have log x base 10 common to both sides, and I can replace them with a letter to make my solving more convenient for me. So I can say let log x base 10, since it appears on the left and on the right hand side, be m. So anywhere there's log x base 10, I'm putting m there. So I'm going to rewrite this one and replace the log x base 10 here and the one here with m. So I have 3 m 3m raised to the power 2 equals 1 plus 2 log x. That one now becomes 2m. Then rearranging, I have a quadratic equation here. So I'll have 3m squared minus 2m. Then the plus 1 becomes minus 1 also on the left hand side. Then nothing is left on the right. You have equals 0. Then this is our quadratic equation. Then we can solve the quadratic equation. So we'll have, let me divide this. So solving the quadratic equation, 3m squared minus 2m minus 1, we're going to use, we might just use factorization method to make our work fast. We have 3m squared minus 2m minus 1 equals 0. So using factorization method, replacing the minus 2m, I have 3m squared. Then I'll have, replacing this will now be minus 3x minus 3m minus m, or minus 3m plus m suits well, replaces the minus 2m because you owe 3 and you pay 1, you're still owing 2, minus 1 equals 0. So this is the perfect way to factorize. Then finding the HCF of both of these first two values will be 3m, open brackets, 3m squared divided by 3m, I will be left with m. Then minus divides plus, here I have minus. Then 3m divided by 3m, still have 1, close your brackets. Then here, what's the HCF? I have plus, I'll pick 1. Since there's nothing common that can divide, 1 will be our HCF. Then open your bracket. There's a 1 here, so 1 cancels 1, you have m. Then minus divides this plus, you have minus. 1 divided by 1, you have 1. Then you have equals 0. Then of course we have it this way. Then the brackets are the same thing. Factorize the second time. Pick one of these, m minus 1. Then open another bracket and combine the ones outside. I have 3m and plus 1 outside. Combine them, 3m plus 1. Close your bracket, all equal to 0. So if this times this gives 0, it means either m minus 1 equals 0 or 3m plus 1 equals 0. So from here I have m equals 1, and here I have 3m equals minus 1 if plus 1 moves over. Then dividing both sides by 3, I have m equals minus 1 over 3. But while solving on this part of the solving sheet, we made log x base 10 to be m. So I will bring that back. Say, but m equals log x base 10. So I'm bringing it back. So I'll solve for this, and then I'll solve for this. Yes, I'll fix the log x base 10 back as my value for m. So let me continue this way. So we now know that m, for this part, m equals 1. That means log x base 10 equals 1, since m is log x base 10. Then we know that 10 raised to the power 1 must give us this x here. So now have x equals 10 raised to the power 1, which is still 10. So that's our first value. Then for this part here, we have m equals minus 1 over 3. So we have log x base 10 equals minus 1 over 3. The same drill, 10 raised to the power, the whole minus 1 over 3 must give x. So we now have x equals 10 raised to the power minus 1 over 3. And then we can still break this one down using law of indices. The negative fractional index here will inverse the whole number. So we now have x equals 1 over 10 raised to the power 1 over 3, which can also be written as 1 over the cube root of 10. So that's it. Very easy.